So in this exercise, I have an integral that I need to solve. And before I start solving the integral, the first step that I need to do is actually find the method in order to solve this integral. Well, first, I'm going to solve the indefinite integral. So I'm going to assume that there are no boundaries. So rewriting this integral, I would have just an integral with no boundaries, sinus of the square root of x over 2 times the square root of x dx. And we notice here that I have a sinus function, and inside the sinus function, I have my argument, the square root of x. And so here I have a function that is, so to say, inside of another function. And then this function, the sinus function, is divided by what looks like the derivative of whatever is the argument of the sinus function. And this is a perfect call for the substitution method. So here I would use then the substitution method. And using the substitution method, I have to rewrite this integral in terms of another variable, so to say u. And the argument here that is inside my sinus function, I'll call this u. So I have to express it in terms of u, and I have to express the dx here in terms of du. So dx is equal to something du. And I can do that if I take the u here and I differentiate it. So my u here is equal to the square root of x, and that is equivalent to x to the power of half. And when I derive that, so u prime, which is equal to du over dx, is equal to, using the power rule, half times x to the power of minus half. And now all I need to do is transform this expression right here and solve for dx. Du here would be equal to dx times 1/2 x to the power of negative half, and then dx would be equal to du times 2 times the square root of x. And why here the square root? It is basically x to the power of 1/2. When I multiply both sides by that, then the negative sign will get cancelled. So I'll have the square root of x here. And so now this term and this term, I substitute back into my integral so that I will get the final transformed integral, sinus of u over 2 times the square root of x, and dx was equal to du times 2 times the square root of x.
If you got any unsolved problem in the world of numbers and equations, make sure to comment it down below and we can get it solved.
And here, to simplify this transformed integral, the numerator will get cancelled with the denominator, and I will have left in the numerator the integral of sine of u du. And I can solve that. This integral is simply just equal to minus cosine of u. And I'm not at a constant here now because I need to solve this integral with boundaries at the end. But I need to substitute first back for u, because the boundaries here that I'm talking about, they are x is equal to. So here my x0 is equal to 0, and x, the second boundary, the upper boundary, is equal to pi. And so therefore now I transform back. So minus cosine of, and u is equal to the square root of x. So I'll have here the square root of x. And now my boundaries, basically minus cosine, square root of x. Boundaries go to from 0 to pi. So that means I'm going to have negative cosine square root of 0, which is basically just 0, plus cosine square root of pi. Cosine of 0 is equal to 1. Now negative cosine of 0 will then be negative 1 plus cosine of square root of pi. And that would be my final, most simple answer without using the calculator.
Don't forget to subscribe to Sam's Education channel and hit the notifications bell to receive regular updates and access to a variety of solved exercises. See you in the next video.